Hello and welcome. Have you ever wondered what's really going on behind the screen of your favorite app? Well, today, we're going to pull back that curtain and look at how professional software is actually built. And spoiler alert, it's a lot less about that frantic late-night coding stereotype and way more about disciplined engineering. Okay, let's get into it.
I mean, think about it. We've all been there, right? You're about to finish a level, you're trying to make a purchase, or you're sending a really important message, and poof, the app crashes. But then you have other apps that just feel so solid, so reliable, you think they're unbreakable. So what's the difference? It's not luck, I can tell you that. It's all about the process.
You see, on one hand, you've got what most people picture, this kind of chaotic coding. It's a tangled, unpredictable mess that, yeah, it might work for a little while. But on the other hand, you have software engineering. And that is a structured, disciplined approach that treats building software with the seriousness it really deserves. And that is the secret sauce to creating technology you can actually rely on.
Now, to really wrap our heads around this process, we're going to use an analogy that I think makes it all just click. Building a house. I mean, you wouldn't just start throwing up walls without a plan, would you? Of course not. And it's the exact same idea for software. This is the core idea right here. Building amazing software isn't some kind of magic or mystical art form. No way. It's a craft. It's a lot more like architecture and construction, and it follows a really logical, predictable path from just an idea to the finished product. So, just like any great construction project, it all starts with the blueprint. In the software world, this is hands down the most critical phase of all. It's called defining the requirements, and it's where we figure out exactly what it is we're supposed to be building. So, these software requirements, they are the official blueprint. It's this super detailed process of defining and writing down everything the customer needs the software to do. Getting this part right is everything. I mean, if you get this wrong, the entire project is basically built on a shaky foundation from day one.
And these blueprints, they usually get broken down into three main types. You've got your functional requirements, which describe what the system actually does, like letting a user log in. Then there are the non-functional requirements, which are all about how it does it. Is it fast? Is it secure? And finally, you have domain requirements. These are industry-specific rules, like, say, HIPAA compliance for medical software.
This table really lays it out nicely, side by side. So functional is the what. The user can transfer funds. This is the stuff the customer usually specifies. But non-functional, that's the how well. That fund transfer has to complete in under 2 seconds. That's usually defined by the architects to make sure the thing actually has some quality to it. And, creating this blueprint is a whole structured process in itself. First up is a feasibility study, which basically asks, hey, can we even build this thing? Then you have elicitation, which is all about gathering what everybody needs. Specification is where you actually write the blueprint down. Validation is crucial. You show it to the client and ask, is this what you wanted? And finally, management, which is just about handling changes because, let's be real, plans always evolve.
So here's the bottom line. Skipping or rushing the requirements phase, it's just a terrible idea. It's literally like a construction crew showing up to an empty plot of land and just guessing where the walls should go. The result? It's pretty much guaranteed to be a total disaster.
All right, so once we have that approved blueprint, it's go time. This is when the construction crew, our developers, actually start building. But as you're about to see, the work doesn't just stop when the house is built.
This is the part everybody pictures when they think of software, right? The developers take those super detailed blueprints and start translating them into a real, working application with code. But here's where our analogy gets a little different. Because unlike a physical house, software needs constant upkeep.
Just think about your own house for a second. You got to fix a leaky faucet eventually. That's what we call corrective maintenance, or just bug fixing. You might upgrade your Windows to be more energy efficient. That's adaptive maintenance, kind of like updating your app for the newest iPhone. And sometimes you have to replace old wiring before it causes a fire. That's preventive maintenance, fixing old code before it has a chance to break.
Okay, the house is built. It looks great. But before anyone can move in, you absolutely need an inspection to make sure everything is safe and up to code. Well, in software, this is the testing phase, and it is absolutely vital. Now, there are two main ways to inspect the work. There's white box testing. This is when the tester can actually see all the internal code, just like a home inspector looking at the plumbing and wiring inside the walls. And then there's black box testing.
This is where the tester can't see the code at all. They're just testing it from the outside, like a homeowner flipping a light switch to see if it turns on.
And this inspection, it happens at a bunch of different scales. So unit testing checks the tiniest little pieces, like making sure a single brick is solid. Then integration testing checks if those bricks actually work together to form a strong wall. And finally, system testing checks the whole house to make sure its overall structural integrity is sound. To be really, really thorough, engineers use some powerful techniques, like something called decision table testing. And all this is a systematic way to map out every single possible combination of user inputs to make sure the software always does what it's supposed to do. It takes all the guesswork out of it and helps ensure you've covered all your bases.
Let's just look at a simple login screen. This table maps out every possibility. So, case 1, email's correct, password's correct. Great, send him to the home page. Case 2, correct email but a wrong password, you gotta show an error. By filling out a table like this, testers can guarantee they've checked every single scenario. No stone is left unturned.
And this right here really brings the risk into focus. Would you ever buy a house that wasn't inspected? A house that might have faulty wiring or a cracked foundation? No way. Releasing software without doing this kind of thorough testing is just as reckless. It is a recipe for disaster, for crashes, and for really, really unhappy users. Okay, so let's tie all of this together. Why did we spend all this time talking about blueprints and construction and inspections? Well, it's because the process is what separates success from failure. It's that simple. You know, the myth of the lone genius coder hammering away in a dark room and creating a masterpiece, it's just that, a myth. Software that is reliable, that can scale, that's safe to use, that stuff is the product of a team following a disciplined, predictable, and rigorous engineering process from the very start to the very finish.
So, if you remember anything from all this, I hope it's these 3 things. 1, always start with a clear blueprint by figuring out your requirements. 2, build with discipline, and remember that planning for maintenance starts on day 1. And 3, inspect your work, thoroughly, at every single level.
And I'll leave you with this one final thought. This isn't just about our apps crashing anymore, not by a long shot. Software now controls our critical infrastructure, everything from financial systems to cars to medical equipment. When the process is done right, it powers our world. It just works. But what's the real cost? What's the human cost when it's done wrong?